Hi, my name is Anshul,
My name is Aaron.
and today we're doing our image classification machine learning model to distinguish between healthy and diseased beans. So, the goal and purpose of our machine learning model is to successfully classify between bean leaf images. The reason we chose this is because we noticed that in our research that beans are super important in African countries. A lot of the African population requires beans as a source of their food. And so if a disease were to impact the bean leaves, then it would reduce the yield, and this would affect marginalized communities heavily.
And we successfully did this by using various libraries such as TensorFlow and Keras, which I will be talking more about further in the presentation. Deriving from this, we also used convolutional neural networks, also known as CNN, and their functions as well.
So here's our data. So we got our data from something called the TensorFlow dataset. What is really cool about this is that they have a lot of data for a variety of different topics. But in our case, we chose something called beans. Now, some examples of different images in the beans dataset is angular leaf spot, which is these images right here, bean rust, which are these images, and healthy leaves, which are these two images up here. Now, after running our model, our confusion matrix showed that 44 images predicted diseased bean leaf correctly, 23 images predicted normal bean leaf correctly, etc., etc. You can read that. The accuracy of our test data set is 76.56. Our recall is 87.2%, which shows the relevant cases within the data set. And our precision is 79.79%, which is the quality of our positive predictions. Hi, so this is our demo for the image classification project. So here we have three things. One, we have our model's prediction that a specific image right here is either disease or a regular bean plant. Here we have our model's predictions for each individual image of a bean plant, and this is the ground truths. So let's look at the second one right here. So here it's our model said that there's a 64.6% chance that this image right here is bean rust, which in this case it's correct. If we look at our second thing, it says that it is a bean rust, and in our ground truths, it says the same.
Like mentioned before, two of the libraries that we used were TensorFlow and Keras, and we learned a lot about these libraries. We learned that these are essential when classifying images, as well as CNN. And what CNN basically does, it extracts features from the images using filters. And after doing this, it creates a feature map, which is important when actually classifying the image. A way that I thought about this was in a visual representation, which was flashing a flashlight over an image, and each time you get closer, you are able to see more of the image or more features of the image, which is basically what CNN does in the actual layers. These layers include max pooling, dropout, and flattening the actual the image. And max pooling, it extracts the maximum amount of features in the filter, maximum amount of pixels in the filter. Dropout increases our accuracy, or no, decrease the chance of overtraining our data. And flattening basically extracts the features from the feature map and creates a one-dimensional array to classify our images.
Some of the minor things we learned is to use a GPU hardware accelerator to make our model run faster. To use the TensorFlow database is another minor thing we learned, and to convert images to arrays and vice versa is another minor thing we learned.
Some challenges we faced, which are the most important ones, is our understanding the libraries, and we overcame this by doing extensive research. From basically, we used 1 to 2 days of our time to do this. And another minor challenge that we had was not having enough RAM, and we did this by reducing the epochs. As well as the applications, we believe that an important aspect is to implement this would be to have farmers have a device that could potentially identify whether a leaf is diseased or not, which could mitigate the chance of having these diseased leaves consumed by people in Africa. For our future research, we wish to enhance our accuracy and overall better our matrix model, as well as using broader data sets, which would expand our variants, and as well as the type of beans that we are using. And lastly, we would like to take it a step further by doing object detection, which is a lot more difficult than object classification.
Thank you.